Hi everyone, Oksana here. Can you hear me well? Victoria, do you want to make this video public? Okay. So feel free to join with me on this video and say hello so we can interact with you. And also you're welcome to share this video with anybody who you think might benefit from the information shared here today. Hi, Stefan. Hi, Nicole. Hi, Sarah. Hi, Cindy. So I'm just gonna wait maybe a minute to see for other people to join. Hi, Lillian. Yeah, so in this video, well, first of all, I'm gonna introduce myself. Some of you might not know who I am. And so my name is Oksana. I work as an immunologist for the last 7 years in cancer research. I've been studying various cancers and designing immunotherapies for the treatment of pancreatic and ovarian cancers, as well as other solid-based tumors. So thank you for joining me again in this video where we'll talk about understanding cancer and disease progression. Nobody wants cancer, nobody wants diseases, and it's one of the most painful diseases, cancer, that sometimes can be dragged on for years. So today I'm going to help you understand what causes cancer and how your diet plays a very important role in preventing it. So let's start with at the beginning, what causes cancer. Well, cancer is initiated by damage to your DNA. So many different things can cause damage, such as UVB radiation, even normal metabolism, and a variety of different carcinogens that we're exposed to on a daily basis. So does this make sense? So many different things can cause cancer, including a normal metabolism. So you can think of damage to your DNA almost like something that is sitting on top, attaching itself to your DNA. And if it's not repaired, this can potentially form a mutation. So every organ in your body is made up of cells, and each of these cells have their own DNA. And this DNA is made up of thousands of different genes. So in order for your different organs to continue functioning, these cells have to make copies of themselves because cells have a very limited lifespan. So in order for them to make a copy of themselves, they have to copy all the DNA inside of that cell. And if there's a damage to the DNA, when the cell copies, the DNA it forms has a mutation. And once you form a mutation, there's no turning back, and mutation is permanent. So it's very, very important to repair the damage to the DNA before it forms a mutation. Does this make sense? Do you have any questions about it so far? So why doesn't all of your damaged DNA get repaired? So, well, in order for your damaged DNA to be repaired, this requires the action of DNA repair enzymes inside of your cells. And these DNA repair enzymes require important and essential vitamins and minerals to work properly, such that in the absence of those nutrients, DNA repair activity is decreased. So when we work with clients who have autoimmune diseases and chronic illnesses, we ensure that they are getting every single tool, every single nutrient oversupplied into their cells so their cells can repair damaged DNA. Without those things, repair won't happen. So I already mentioned that if you cannot repair damaged DNA, this can potentially lead to cancer-causing mutations. Once you get a mutation, it's permanent. There's no turning back. It's a point of no return. And this is why it is extremely important to prevent a mutation and reverse any unmutated damage you already have through diet, making sure you have the proper levels of essential nutrients in your cells. So even if you avoid all of the known carcinogens, it is impossible to avoid damage to your DNA. Just like normal metabolism, the way that our body generates energy damages your DNA on a daily basis, and there's no avoiding it. So it's important to keep the defense mechanisms working at their best. So another defense mechanism that your cells do in order to protect themselves from cancer-causing mutations is that they sacrifice themselves. They self-destruct for the greater good of organism. And this is referred to as apoptosis, programmed self-death. This is genetically defined program. Have you heard of apoptosis before? If you have, just let me know in the comments below that you heard of it, what it means. And apoptosis is very important. So there are certain genes in your cells that have the ability to detect damaged DNA. And when they detect this damaged DNA that is unable to be repaired, they immediately activate apoptosis, the certain genes. So now these genes are often referred to as tumor suppressor genes in terms of cancer. And that's because they suppress the formation of cancer cells. They're called tumor suppressor genes. So now, tumor suppressor genes are fantastic defense mechanism, but there's one problem. There's one problem. What do you guys think that is? So if you get damage in that part of the gene that contains the tumor suppressor gene or any other gene that prevents you from diseases, and if this happens, what could end up happening is that you get a mutation in the tumor suppressor gene, which now disrupts the ability and function of the gene to detect damaged DNA. And now ultimately, this can rapidly lead to cancer and disease progression because these genes are very important in the defense mechanisms that our bodies have against cancer and other diseases. Does this make sense? Any questions about it? So you may be asking yourself, well, what determines whether a mutation forms in a tumor suppressor gene versus any other of the thousands of genes that make up your DNA? And the answer is simple. It's random. It actually happens through random mutation. So that means damage of your DNA happens at random places. And there are thousands of different places that this DNA damage can occur. So more damage you happen every single day, the more likely you're going to get it in the gene that is a tumor suppressor gene. So it often takes several decades before you actually get a mutation in the tumor suppressor gene. And this is part of the reason why cancer is often a very age-related disease, such as heart disease as well. It's all about having this chronic inflammation happen this time after time after time, and not giving your cells enough tools that they need to repair the damage and recover. So here's where your diet comes in. Certain foods have organic compounds that increase the expression of these tumor suppressor genes and various other genes needed to help us fight disease and even reverse it. So we engineer specific protocols for each client based on their health issue to create a most rapid healing possible in a rapid healing program. So these tumor suppressor genes can now have a better ability to detect damaged cells and kill them before they were able to cause cancer, causing mutations. Not only can these compounds found in certain foods can detect precancerous cells and prevent them from forming mutations, but they can also kill cells that have already formed cancer. Now that you understand some of the basics of what causes cancer, which is mutations over time and disease progression, how your diet plays a role and how to prevent it, you can think of what you can do right now to bulletproof your health. And if you need hands-on help, then apply to join a healing program. You can apply now. That starts in January 7th. And to do so, you can click on the link in the comments below that my sister is going to share. And we won't, on the call, we're going to disqualify you pretty quickly because the program is not for everybody. And we won't tell you to do anything that is not good for you. But if you are fit, we are going to invite you into our program. And it starts January 7th. It's really important for people who already have chronic illnesses, and you need to do anything you can possibly do to help you heal rapidly. So I hope you enjoyed learning some of the basics of understanding cancer and how your diet plays a role in a very important role in preventing it, such as activating tumor suppressor genes and other genes that help us combat cancer. And if you have any questions, put them in the comments below. And also tag anybody that you think might benefit from this information. Okay, bye everyone.